My name is Armand Villani, and our group is doing radiative power transmission. In the last week or so, we've made some progress. We're working towards finalizing a design for a feed element for our reflector dish. We're working on manufacturing techniques for that dish, and we've begun simulating some preliminary designs. So to talk to you about that more, I'm going to pass it on to Jordan Hibben, and he's going to take it from here. Jordan.
My name is Jordan Hibben, and I'm going to talk to you about our HFSS simulations for our antenna array. Here is a picture of our diagram in HFSS. We've got our substrate here, which in this case is FR4, and then the red blocks here are our antenna elements. This black lines here are our feed lines. So what we did was we tried to do an uneven spacing that is symmetric among this axis and this axis. After building the array, we then decided to simulate it and see what our patterns look like for our radiation. This is what our radiation pattern looks like in the phi, which as you can see is absolutely awful. We're shooting for a 90 degrees here. Here is the gain in the theta. Now you can see it's pulled in closer to 90, towards 90, but it's still really bad. And this is what the composite looks like in 3 dimensions. We're still shooting for a radiation pattern in this direction, and it is not there at all. In fact, it shoots right through our ground plane and then off in these 2 directions. So we've learned from this that our antenna array is absolutely not going to work, and we have to reevaluate what we're going to do and what type of array patterning we're going to do. And moving forward, we'll continue to simulate with that. I'm going to pass it along to Alex here, who's going to talk to you about the manufacturing and fabrication of the radiation dish.
So, we've been thinking of some different ways, or looking into different ways, to try to make a really precise parabolic reflector. Now, we don't actually have to make anything yet, because we're still in the design and research phase of this project, but I thought, what better way to find out a good method for making paraboloids than just by trying a few out? To that end, I was going to show you guys. So one method we could do is what's called a press-fit mold. Basically, we'll have a positive, like if you can see the curvature there, and negative mold of our parabolic reflector. And we'll take whatever we want to make the reflector out of, for example, like a piece of sheet aluminum ideally, but we'll show it here with a piece of paper, and just place it in between and gently press the molds together. There. Kind of like that. As you can see, the sheet here kind of takes on the form that we want. As you can see, it's not really ideal. There's kind of a lot of kinks in here, and that's something that we'll have to be careful of. It won't be as big of a problem for aluminum because being, sheet metal is quite ductile. Now, this is a scale model of the parabola that we would like. See, this is about 2 inches diameter and has a focal length of about 1 inch, so our reflector, our antenna would be right around here. We're thinking of doing something that's about twice this size, but we'll see what works best, because these are quite cheap to make, so we can just make as many as we want and try them all out. That'll keep us occupied on the parabola front for a while, but concerning the rest of the project and how we're going to be moving forward in the schedule, here's James to fill you in on the details.
So like Alex said, we're trying to keep this on the low budget side of things and trying to manage a project that so easily has so many things juggling at once. Manufacturing and prototyping and design, all of these things kind of can happen simultaneously. And right now we're trying to figure out what pieces we need to get done by the end of the semester and what information we can include in our final proposal, so that next semester it's just a matter of getting our materials and making assembling a functioning prototype. So hopefully by the end of next semester this thing works out and there's no kinks